Now we'll see method of finding the complementary functions. So consider I have taken one a simple differential equation of order 2, that is d square y upon dx square plus a1 dy by dx plus a2 equal to 0. Fine. So what we'll do here, replace this d square upon dx square. I am keeping y as it is, only d square upon dx square as capital D square, and this d upon dx square will replace as what here, d. So what happens here, then see, this d square upon dx square is replaced by capital D, this y as it is plus a1 as it is. So d by dx is replaced by capital D, and this y as it is plus a2y equal to 0. So among this, we have three terms, 1 2 3. So this term having y, 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 so you take y common, what left here, d square plus a1 into d plus a2, which is nothing but we will call this bracket as what here, function of d of y equal to 0. Now auxiliary equation means what, the function is multiplied to the function of d, will leave, that means you equate to 0. This f of d equal to 0 and y equal to 0, y equal to 0 is meaningless, you leave it. So f of d equal to 0 is going to called as of the form auxiliary equation. So from this actually we will get roots, that is I will consider first root as d m1 is m1 and second root as m2. So these roots are, maybe we have these roots having three kinds here. So first kind is what here I will call as, this is real and distinct. Real means this, just check here once again, I'll repeat. So from this root, this what root we got, d is equal to m1 and d is equal to m2. The quadratic equation we have always, because why it is two root, because the given equation having what here, it is a quadratic equation. So therefore we have three kinds of root here, this m1 and m2 having three kinds, that is real and distinct one way. Next part is real and coincident. Coincident you can consider as one more meaning as same or equal also. Find complex root. So I have given a chart here. So this is CF. So roots. So I told, so first one is a real and distinct root. Second one is a real and same or equal roots, and third one is what here, complex root. So how to write for real and distinct? Real and distinct means just you go through this. So I will take one example for this and I will explain. So if roots are real and distinct means not same, so for example 2 here, 3 here, or -1 here, -2 here. So for such kind of roots are going to called as real and distinct. So how to write CF for this? C1, because 2 root means therefore C1 and C2 will come. So we have to take the addition. So it will C1 into e raised to the first root into x. This x, how to write x? Because we are differentiating with respect to x, that x will come here, plus C2 into second root e raised to m to x. So this is a complementary function for real and distinct. Next we will see a real and coincident root. For that roots will be same, means sometimes on solving differential equation we will get, so real and coincident root, that is same roots. So at that time what happens, because of same root we'll make it as a common root as m1, that is c1 plus c2x into e raised to m1x. So next root is complex. So alpha, I have taken general form, alpha plus or minus I times beta. So we need to write a complementary function as e raised to alpha x. So what real part, this is real part and this is imaginary part. Okay, so this is real means, so e raised to real values what we'll get into c1 cos of beta x plus c2 sin of beta x. Now I will take few examples how to write CF. Just this is a practice here. So how to write CF we'll see. So you just see here, if these D is equal to 2 and D is equal to 3, these are the two roots for, okay, I have taken. So these are the two roots, but just you observe here whether it will be real and distinct, or real and same, or complex. So here this is not complex, these are not same, that is, so there are real and distinct. Distinct means different, so both the roots are different. So CF can be written as what here, and write as C1 e raised to 2 into x plus C2 into e raised to 3x. Second example, here I have taken four roots. Just see, d equal to 1, d equal to minus 1, d equal to 2, and d equal to minus 2. All four roots are different, but they are real. So therefore C1 e raised to x plus C2 e raised to minus x, because 1 into x is nothing, minus 1 into x is minus x, plus C3 into 2 times x, plus C4 into e raised to minus 2 times x here. So this is the complementary function for four roots. Next example I will take here. Uh, D is equal to 3, D is equal to, means here roots are real and same. So for this, how to write here? So C1 plus C2x into e raised to x, 3 cube, 3 into x here. So what here? C1 plus C2x into e raised to 3x, because roots are same. Then if roots are d equal to 0, d equal to minus 2, d is equal to minus. So here they are real, but first one is what here, different, and but remaining two are same. So for the, it is a mixture of what here, our first kind of root and second kind of root. First kind of root is real and distinct, and second kind of root is what here, real and same. So at that time, for the first root we'll write C1 into 0 into x, plus for second type what we'll write, C2 plus C3x of e raised to minus 2x. Next, coming to the next kind of example. So D is equal to 3 plus or minus I2. So this is nothing but a complex root. So for this, how to write CF? E raised to 3x C1 cos 2x plus C2 sin 2x. So here e raised to 3, this 3 is nothing but real number, you take it, and cos of angle what we are multiplying to x is nothing but the imaginary part of the given complex root. So similarly here d is equal to only plus or minus I3. Here real part what we have, it is 0. So at that time e raised to 0 will not come here. So only we will get what here, imaginary part, C1 cos 3x plus C2 sin 3x. Next, so we may find one more kind of root as d is equal to 1, d is equal to 1, d is equal to 1 plus or minus I. Total 1, 2, 3 with plus sign, 3 with minus sign, one more 4. Total 4 roots are there. So if 4 roots are there, means we will get 4 arbitrary constant, 1, 2, 3, 4, C1, C2, C3, C4. So therefore, how to write? So first two are same. So at that time we can write the complementary function as C1 plus C2x into e raised to x plus, so for this is a complex root. So for this we can write, so real part is e raised to x bracket of, next we have to continue the complementary number here, that is C3 cos of, coefficient of I is 1, cos of 1x plus C4 into sine of 1x. Next, if root d is equal to 1 of plus or minus 2i, and d is equal to 1 of plus or minus 2i. So here these two are complex but repeated one. So at that time, how to write the complementary function is e raised to x c1 plus c2 x of cos 2x plus c3 plus c4 of sin 2x, because here real part and here real part is same, that's why e raised to x. So imaginary part is same for both, so here it means what, here repeated one. So c1 plus c2 of c2x of cos 2x plus c3 plus c4 x of sin 2x. So in this way the general examples I have taken for you to show how to write a complementary function here. And in the next this one kind we'll see the particular examples.